Okay, let's move on to the next subject, which is network/subnet. Those two terms are pretty much interchangeable. And what I have here is a section of a larger network. Okay, well, whoa, big deal. What does that mean, and why do we even care? Okay, well, if you've ever heard the phrase tip of the iceberg, this is a good example, because what we've just done is we've touched the very tip of a very large and very deep subject. The world is filled with millions upon millions of computers. And if all those computers could talk to each other at the same time, all the time, what would happen? The network thereon would become so saturated with crosstalk, actual communication would become impossible. So we have to find a way to divide those networks up so that only computers that are related to other computers in some way can communicate with each other. So how do we do that? We do that with the system of IP addresses we just got done talking about and something else called subnet masks. Now we'll get into subnet masks a little later. Right now I want to talk to you how we use IP addresses to separate networks. Okay, let's look at some IP addresses. These computers here are all on the same network. You'll see there's a really big similarity between them. They all start off with 192.168.0. Whereas down here the networks are pretty close, except for this one, but they're still really similar. So what's the difference? In order to understand the difference, we have to take a closer look at IP addresses. Now, while IP addresses may look like just one simple string of numbers, an IP address is actually comprised of two parts. There's the network portion and there's the host portion. The network portion basically shows which network the host is on, and the host portion basically shows which computer, printer, or other network device we're talking about on that network. So it's kind of like a street address. The network portion, which in the case of this IP address is 192.168.0, is kind of like the street. And the host portion is kind of like the house on that street. So this IP address is kind of like saying house number 12 on street 192.168.0. And this IP address is kind of like saying house 132 on street 192.168.0. Well, that's pretty easy to understand. But things start getting a little bit different down here. What happens down here? We have three houses or three computers with host addresses of 1. Now we look here, we have 192.168.1, we have 192.168.2, we have 192.168.0. These are actually three different networks. Same host name, different networks. If we were to change all these to all 1s or all 2s or all 0s, it would all be on the same network, but guess what? We'd have an IP address conflict because they'd all be using the same IP address. So far, if you're following along with what I'm saying, it appears that we're saying that anytime the first 3 octets, that's what we call these things, octets, are identical, they're on the same network. Whereas if they're different, they're on a different network. Well, that's not always the case. Where the network portion ends and the host portion begins on an IP address is not always the same. It's determined by something called a subnet mask.